Determining the hybridization of an atom in a molecule is a very important skill. Remember, it's hybridized orbitals that overlap to form many covalent bonds, so determining hybridization is vital. The hybridization of an atom in a molecule is determined by counting the number of electron groups around it. Remember, a single, double, or triple bond are all counted as one electron group, and this is a very classic mistake for students to count, say, a triple bond as 3 electron groups because you see 3 lines in it. This is not right. A single, double, or triple bond is counted as 1 electron group. Also, a set of lone pair electrons is counted as 1 electron group. And if you remember, we also counted electron groups when we were using VSEPR. So hybridization and molecular geometry are linked together. It's actually the hybrid orbitals that orientate themselves into the 3D plane space to form the molecular geometry. So the same way that we counted electrons when we were using VSEPR, we are counting electrons here. It's very simple. If you try not to overcomplicate it, when you count the electron groups, there's the corresponding hybridization. The hybridization starts out with sp, and that's for 2 electron groups. 3 electron groups is sp2, 4 electron groups is sp3, 5 is sp3d, and 6 is sp3d2. So a little trick here, if you count the number of orbitals in your hybrid orbital, this should equal the number of electron groups. So 1s and 1p, 1 and 1 equals 2, 1s and 2p, 3, 1s and 3p is equal to 4, 1s, 3p, and 1d is equal to 5, and 1s, 3p, and 2d orbitals is equal to 6. Remember, we only have 3p orbitals inside of the valence of our atoms, so the hybridization after you get to sp3 cannot continue on to, say, sp4. When we get to 5 and 6 electron groups, we start involving d orbitals. So an example of what we're talking about here, we ask what's the hybridization of the central atom in this molecule. Here we're talking about the phosphorus. All that you need to do is count electron groups. So we have 1, 2, 3, 4. When you have 4 electron groups, the hybridization is sp3. So this phosphorus is said to be sp3 hybridized. When we look at SF4, the central sulfur, we have 1, 2, 3, 4, 5, 6 electron groups. When we have 6 electron groups, the hybridization is sp3d2. So our sulfur is sp3d2. Here we're asking for the hybridization on carbon for this last one. Carbon has 2 electron groups. So remember, this triple bond is counted as a single electron group. So the carbon in this case has got 1, 2 electron groups. When you have 2 electron groups, the hybridization is sp. So this carbon is sp hybridized. So literally finding hybridization is as easy as counting electron groups around a particular atom.